combustion and explosions. So there's two types of combustion classified by how fast the combustion occurs. The first is called deflagration, and that is the slower type of combustion, and it's by far the most common. So something as slow as a burning candle, or even something like a firecracker. So low explosives are considered deflagration. When the combustion occurs much faster, and in fact when the rate is such that the combustion is occurring close to the speed of sound, then we call that a detonation. Now, detonation is much less common. It's basically only with high explosives or extreme situations like atomic weapons. Now here's an example of basic combustion.
All right, let's make some bubbles.
So
I'll have you light the throw the match in.
Creating some bubbles and using a
okay. Okay, here we go.
Propane. Just gonna throw the match in.
Nice.
Okay.
So stinky.
Now, if the combustion is relatively slow, then we don't hear anything, but if the combustion is somewhat faster, then there is some sound that is produced due to the pressure waves. So we have pressure which pushes the air outward. With a simple balloon popping, it's just the difference of pressure inside the balloon to outside the balloon. But with combustion, we can increase the pressure due to the release of energy, and so that can create sound. Here's some examples, some hydrogen bubbles popping.
There we go. It's okay.
We'll do a couple more. There's a multiple one. Nice.
So you hear the pop.
This is way more fun than popping bubbles the regular way.
See one more.
It's weird that they dance up.
Yeah.
So now let's do the same thing, but instead of individual bubbles, we have some hydrogen foam.
Bubble up and then detach, rise, and then just catch it up.
Okay.
Now these are larger, but not necessarily louder.
It's working better.
Anyway.
I didn't expect it to flame so much.
Yeah.
So you see these are
Expecting more of a pop.
deflagrations with some...
It's more like a sizzle.
Yeah.
Now, getting back to the distinction between deflagration and detonation. So in deflagration, the combustion is not so fast, and so we have pressure which produces sound, but that wave is significantly, well, the burning is significantly slower than sound, and so it may be loud, but it is not a shock wave. On the other hand, when the combustion occurs very quickly, then we can produce an actual shock wave, like with produced by sonic booms, but in this case it is the release of energy from the detonation that is producing the shock wave or blast wave. Now, in live action pyrotechnics, you want to have an impressive explosion, but you don't want to use high explosives because they produce blast waves, and those blast waves can be quite dangerous to anyone nearby. So what is commonly done is to create an impressive deflagration explosion by having a balloon of gasoline, which is basically vaporized and thrown into the air, and then lit using a second smaller explosive. So you use one explosive to throw the gasoline up into the air, and then a second one to ignite it. Now, we can do something similar with a dust explosion. So we can throw a cloud of dust into the air and then simply light it with a candle. So this is an example of a very rapid deflagration. So let's see how that works. I have some...
I'm going to just blow a puff of cornstarch into the air. This looks better with the lights off, so...
So you see the cornstarch dust was coming out of the pumpkin, and then the bottom caught fire with a candle that is inside the pumpkin, and then very rapidly the whole cloud is lit on fire, and the cloud rises due to buoyant convection of the hot air. Now, cornstarch is not particularly flammable, but when you have a cloud of dust, because of all the oxygen that is surrounding each individual grain, it can burn in an explosive fashion. Another example is grain, which sometimes explodes in silos if there's too much dust and perhaps an electrical spark sets it off. And even more dangerous, coal dust explosions that sometimes occur in coal mines. Now, when special effects does an explosion without using computer graphics, when they actually film an explosion, of course, as we saw, an explosion naturally has a rising plume due to the convection of the hot air. Now, if you want to film something that appears as if it's an explosion in space, then the trick is to put the camera on the floor and have it looking up at the explosion. You typically don't want to put the camera on the ceiling looking down at the explosion because there's often a plume of smoke which is coming up. So in order to avoid looking at the smoke, you put the camera on the floor. And this is how the original Star Wars Death Star explosion was filmed. Now, with high explosives, you have a blast wave that is produced by a detonation. And this is an invisible high pressure shock wave that travels faster than the speed of sound. You see this in this photograph where there was a large TNT explosion, and this rippling that you see on the water is the shock wave as it has passed over the surface of the water between the ship and the shore. Now, we can create a shock wave in the lab without use of explosives by simply using atmospheric pressure and vacuum. So we create the pressure difference using a vacuum pump. So what I'll show you is a shock tube that we have where we put a ping pong ball inside of a pipe, cap both ends, then attach a vacuum pump to the pipe and suck the air out of the pipe so we have a vacuum inside. Then to fire this cannon, we open one end, then a shock wave forms as the air rushes in. That shock wave pushes the ping pong ball down the tube. The other end is capped, and so it's basically vacuum in front of the ball. And then when the ball reaches the other end, it's fired at high speed. So let's see what this looks like. So here you see the tube. Ping pong ball is already inside, capping off the other end, turning on the vacuum pump, sucking all the air out of the tube, and now fire. Here's someone else who filmed it in slow motion. So this type of blast wave, as I said, occurs with high explosives, and the extreme case would be a nuclear blast. Now, with a nuclear blast, here you see a house that is was unoccupied. It was built just for testing of the effect of a nuclear blast on a house. This was done in the 50s, and in the first photo after the blast, you see that there's a very bright light, and in fact that radiation is so bright that it actually causes the house to catch on fire. Shortly thereafter, the blast wave hits, and that high pressure shock wave basically destroys the house. It's like an extremely strong wind that hits it. Well, it's large pressure wave. And then even after the blast wave has passed, there's a very strong wind that causes further destruction. You can see a little bit of this in this recording of Survival Town, where they set up this testing. So they built some housing, and this was occupied by some mannequins. So trying to recreate what a small town might be like. Here's some military vehicles that were also involved in the testing, and they're getting ready to set off the blast. The observers, and here we have the atomic blast, which was set off near the town. There you see the mushroom cloud of the atomic blast, and the strong radiation passing. This radiation, by the way, is not the same as radioactivity. Here we see the effect of the blast wave on, say, a tower. Then more blast wave effects. The radiation igniting many things on fire, and then the high pressure blast wave, and then the back pressure on the house. Here's another house being hit. So if some of that looked familiar, that scene was replicated in Indiana Jones and the Kingdom of the Crystal Skull, where Indy finds himself in Survival Town just before the blast, and he hides in a refrigerator in order to escape unharmed. Rather implausible, but they did a nice special effects of that blast in that film. So, in summary, There's two types of combustion, deflagration and detonation. Deflagration is slow combustion, such as with flames, fire, even gasoline explosions are deflagrations. Detonation is much faster combustion, and this is only with high explosives or things like atomic blasts. A large deflagration is often used in special effects, and this is typically either a dust or vapor explosion. The vapor would be gasoline vapor thrown into the air and lit. And then finally, detonation explosions are not used in special effects because of the resulting blast waves, which are very dangerous. We see that these are high pressure sonic shock waves that can produce significant damage.